Hello, welcome to the 13th episode of the Specter DIY Builder Call. Today I'm yet alone. Maybe someone is joining later on. At first, what we want to do is to have a look at the challenge we had about the slimmest Specter ever. Let me share the screen. Here we have the tweet. So at first, what was the challenge about? The challenge was about a Specter fan, and he wanted to have a slimmer Specter shield light. So this is the normal Specter shield light. That was the case from Crypto Guide. And you see it's not very thin, and his idea was to have a much slimmer version of this Specter shield light. And he said, okay, I want to give the person who builds a minimum 10% slimmer Specter. So the slimmest Specter of this challenge would, he would bought the Specter from him and would pay 1 million Zs, also 0.01 Bitcoin. And then we had some rules that need to be applied for the Specter. Here we have like all the different things that are allowed or not allowed. I will provide the post in the video description later on. But maybe let's have a short look, as currently no one is in our call. So the first thing is, you need a photo or video of your Specter by the 21st January. This was yesterday. At least 10% slimmer. Maximum. Okay, that's just what we have. So the length needs to be also not like wider. Slimmest Specter can be sold for 1 million. Allowed is removing components from the STM32 board. Don't use shield light PCB or edit it. So you just need to like get the smart card running, editing the size of the smart card, scanner modules. You can use different ones, and other scanner modules are only accepted if they would support it, of course. Then what's also important that you need a case. You need like functions working properly, including smart card. Then the deadline, and here we added that you need also provide a brief manual, like how you did it, that like we can share this knowledge, and you, if you're listening right now, you can also build the new flat Specter. And what we received is the one from Motorbrot. He was the only one who participated at this challenge, and let's have a look if he would get the 1 million Satoshis from the work he did. So let's watch the video here in live. It's really cool. I already saw it a couple of times. Really flat and really beautiful Specter. Looks not like a shield light. Looks like a here we have it, the normal like snap case, which Thomas did, but it's even smaller than the snap case, even though it's a Specter shield light. Here he has the smart card, plugs it into it. Nice feeling. Okay, everything works, like smart card works. That's like, if it says using smart card, then we know that the smart card works properly. Really cool, like the how he puts it into it. That's just like one flat surface. Okay, works without smart card as well. Touch screen works. Scanning. Now he wants to show how scanning works. Here he has a QR code printed from 3D. Oh, that's interesting. And now we want to see the size. That's the most important part. We have what's that? 2.6 point, like 26 point some millimeters, and now we have 14.83. That is like more than 11 millimeters thinner. Great work. Really impressive. And here you see the sign as well. Then he closes this really confident with this in his bag. It's like really cool. So let's have a look. With like all the work he did, he completely like would be able to get 1 million Satoshi from the Specter fan. One thing that is currently missing, but I already wrote with Motorbroad, and he wants to share it later on. That's the like how to build together the Specter. That's currently not shared. But he said that he's going to take part in the next Specter DIY Builder Call. Then we will have a look about that. But he said that he documented everything well, and that we can share this like later, that you, if you're listening here and you are like a builder, that you can assemble this yourself as well. Probably, I'm not sure, you didn't share it yet, but I think there is soldering and involved. So it is not that like this really easy plug and play like you can use with your normal Specter sheet light, but it is going to be possible for you afterwards to assemble your own Specter sheet light. I'm really curious what and how it looks inside. And yeah, that's about the DIY challenge. So yeah, pity that only Motorbroad applied. Maybe, yeah. That's about the challenge. No one else is joining yet. So let's have a look. What can we do now if no one else is joining? So yeah, I would like finish this now, and we will have a look next call when yeah, Motorbot is going to show everything. And I think after that, then the Specter fan can like buy it from him, because then he also showed like this documentation about it. What also happening about the release, maybe this is like the next important and interesting thing. when we have a look, we are like, the release is really near. We merged the what was it name from Oren about nlog and nsec, like that is shows in the display. This got merged, and also the where we have it, like this key removal got also approved from Mike, and now let me have a look at the links, and got merged from Kanoinat. And so I think we would be ready for the release. Now we need Stepan, because he is like the oops. Oh, I'm in the wrong call. I need to enter stream now, and we'll have a look at the oh shit.
So I think we need to enforce this update first,
Right.
and then any other next
Right.
one in the future.
Yes, I agree. Yeah, so yeah, and we cannot force the people. We just have to make them push very hard to do that upgrade, and probably prepare a FAQ for people who are jumping it. Yeah. Okay. Schnutz is in the call as well.
Yeah, I'm really sorry. This is like I was like in the wrong Jitsi call, and I started like the live stream alone, and did like 10 minutes. Showed the like the
Yeah, it's fine. It's fine.
Yeah, sorry.
Yeah, so then maybe to wrap that up, there is an issue here, planning and executing these, and that is more or less my plan, which I somehow built together. Yeah, and that's what we need to follow through now. Yeah. Yeah, that's it from the release point of view. That's me. So I don't know whether we have anything else, Schnurz or Marco. Marco, you had some questions about packaging your kind of POC onto the machine, right?
As far as I understood, so there was a plan from Mike initially to upgrade the, on the one hand, LVGL plus the Python itself in the repo, and he had a branch for that. And I based the current GUI development on that new version of LVGL. But I understood that upgrade never was completed, so I cannot really bring it to hardware, or I'd have to fix that upgrade myself. An expert on that currently.
I had that impression for some time as well, but I changed my mind insofar that so first of all, the original Micropython Upgrade PR was here, and that was from Mike's remote, but he don't want to take the responsible for bringing it further, at least not until we have some further funding. And so he recommended that we port the branch for the Micropython upgrade directly to the Specter DIY repo. So now the branch is no longer living on anyone's remote, but it's a branch on the directly on Specter DIY. So if we look into what the changes are here, then yeah, so on the one hand side, so what I did here is that I tried to curate the commits in a better way, so that we don't have so much problems with rebasing it, right? But most of the changes here, it might be a little bit confusing if you look at it, but the most important changes are here in the Disco directory, right? So these are the biggest changes here, and that's what's needed in order to flash a device, and that is already working. However, it was like we need to do some more changes for the old part of the old firmware to flash it on the device. And then I realized when I made my hands dirty with the Disco tool, which we might come later on, I realized the problems with the flashing is not that the image is somehow screwed or anything like that. So the flashing is working, but the code is not, right? Because the code might not adapt it to whatever LVGL updates we have. And that is for the old firmware, because the old firmware has dependencies to the old LVGL libraries. So what you did, Marco, is based on the new Python code, and it should be able to flash it. However, there might be issues with the Python code on the device for some or another reason. For example, it could be that maybe the code is too big for the device. Maybe it's not. I don't know what the reasons are.
But what we flash it, I could flash it, but it never executed anything other than I'm not sure even if I could get it to toggle some LEDs. So even without using any LVGL, it didn't really anything, or at least LVGL wasn't able to get initialized.
Well, the question is, how did you test it? So you tested it probably by looking at the screen and seeing whether it comes up or not. That's my guess.
That was the first. No, afterwards, I dug a little bit into it. I took the initial app from the old version, threw out everything, and just started to writing simple commands. And I'd have to check. I think I commented last time what worked and what did not. I'd have to check with with Schnurz, but as far as I remember, I couldn't even so not even touching LVGL, even toggling LEDs was I'm not sure if that even worked.
Yeah, because there is a way to somehow run a debugger and run all sorts of debug tools with OCD or whatever that is. So for that reason, I had some effort. We need a diagnostic tool, simple as that, right? And that diagnostic tool needs to connect to the device and check whether the Python code is running and whether the Python code threw some exception, because that is the most likely reason why your code is not working. It throws exceptions on the device, which does not throw on the simulator, right? And then the question is, how do you work with that diagnostic tool? And I would not say that I have prepared, but maybe we first look into the, let's make a new tab. Do you see the new tab? I hope so. Do you see the please, yes, no. Can you see the new tab?
I think I see the rep. I'm not sure what you mean with the new tab.
So currently there's a simulator in there, but
So we see only like the Specter Lab scripted website.
Okay, wait, then maybe I share the whole, not the break, but the window, and the window should be where's the Brave window? Here. Share. Okay, so maybe that makes more sense. So now there is a GitHub for this one here. And there's a pull request, and it's here for a Disco tool. Yeah, and the idea is that with that Disco tool, you can check out what the current status of a device is, and it has kind of subcommands, and it's very we have some README here. So I didn't program myself, so I used Claude Codes to do that. And we have here some docs, and I think maybe this one is the best. No, it's not. Let me but that's the tool. Maybe we can do a demo, but I don't know whether it will work out. So because I worked for about 2 hours or something like that. Tadeo, thank you for your PR. I haven't realized you did that for the Linux machines, because I initially worked on that on a Mac, and and Tadeusz has a Linux machine, I guess, and he ran it there and didn't work, and he made some changes there, and I just recently merged the PR, and I can show you at least what I'm planning to do here, and which could be copied by you as well. So let me just tidy that one here up.
There are still some between Mac OS and Linux regarding the drivers. So some commands I had to dig deeper, but at least it's working.
It's working for you?
And not all commands. Not all commands, because when one command executes to start I have commented there to start the. I don't remember now, but
that was your comment. Your comment was after your fix.
Yeah, I was building the fixes and commenting about it. So it's not 100%, but at least the commands work now.
Yeah. I don't think I can show anything yet, but at least I can show you the hardware setup. That's maybe interesting. So that's yeah, there's the disco guy in here. So that's currently my setup. You see in the.
Could you, before you start, could you close your
Yes.
like? Then I think it's better to see in the live stream. Perfect.
Yeah. So yeah, this is a mobile from my side, and as you can see, there's a kind of Fischer Technic setup here, where the disco board is placed so that it's facing towards a small Raspberry Pi in the background, and that Raspberry Pi has a display which can show QR codes. And the idea is that we will use that in the future for the CI/CD setup, so that we do a GitHub runner which would be able to take a binary and flash it on a device, and then maybe even run some tests. And this setup is also good for developing the Disco tool, and maybe also for fixing the issues which we have with the old firmware, where we have to upgrade to the new LVGL setup. Yeah, and I would love to show you now a terminal where I have an SSH session and a Claude running, and to flash, for example, an image to the Specter DIY, but I can't do that yet because yeah, I focused a little bit on the security setup, because if I put that Raspberry Pi as a GitHub runner, I really want to make that as secure as possible. And now that user who is mainly supposed to run that stuff cannot do it for all sorts of different reasons. Yeah, but yeah, but using that Disco tool would be the idea to figure out why our software is not, our firmware is not working, and also why Markus is not working. And when I have that working here, that setup, I think it's very easy to also fix Markus issues with the firmware. Unfortunately, I didn't have much time over the years, and there was also some personal problems where I didn't found so much time to work with that. But I think it's I will get it. I will get it done until next week. Let's say next week I commit to that. I will be able to have a much better demo showing this and the Disco tool, how it works, and how you could potentially do that, because you don't necessarily need that sophisticated setup here. That would be especially for GitHub testing, for automatic GitHub testing. But you could potentially use that as Thaddeus did at home with just your device and two cables here, one at the top and one at the bottom. Because the bottom one is the one which makes the connection for Python. And the bottom one is the one which where you can connect the kind of, yeah, machine level debugger, which could hold the CPU and run it again and things like that. Yeah. Yeah, and I'm stopping that now again. So unfortunately, nothing yet working, but I'm really I had it already working without such a sophisticated setup, and I can show you that the last commits. Let me share my screen again. So I think yeah, that's a disco tool. Exactly. Yeah, we need to look at the other. Oh, you cannot see that. I have to do it like this. So looking at the upgrade pull request, there are a couple of commits, 8, and one of them is this one, which did a lot of tiny changes to the Python code, and that has been done thanks to the Disco tool, because otherwise I would never have figured out it's exactly working. We cannot merge it like that, but we can have a POC that this will work, right? So because this is mainly by so small disclaimer here, right? So when we have the upgrade of LVGL working as a POC, as a proof of concept here in this PR, we will probably need to cut the huge changes into reasonable commits, which are then reviewable by human beings, because Claude Code and AI is a great help, but AI is not able to click any approve button. And if we approve something, it needs to be secure, because there's a lot of money on the line, and we don't want to have some hallucinating AI put code in here. So we need to make that into chunks of code which are reliable, secure, and human reviewed, right? And that is, from my point of view, that is not really reviewable in that sense. At least, yeah, that we need to put extra effort in it. But that's not relevant for Marco, because for Marco we could go and the AI run to figure out what's currently not working on the device via the diagnostic tool, and then make subsequent changes, deploy them again, compile them again, deploy them again, check whether it got improved. More or less automatic process, which needs not so much hand holding. Yeah, does it make sense?
So you want to let the AI run automatically in loops to find out, just to find a way to make it work?
Yes.
Because I have my doubts that this will work, because at least what I encountered is if you just let it iterate on itself without any guidance, it is very likely to get stuck in some sort of say going down some rabbit holes it shouldn't, and that don't lead to success. So I mean, it could work. There's a chance it could work, but I wouldn't be too optimistic on that.
Yeah, well, it depends on. So it depends on, because yeah, you're right in that sense that you need a lot of hand holding, because the way I started this was, I hope I have this still somewhere available. It should be in the I guess I have a maybe R here. Or maybe it's on my fork. No, I don't. I can't the branch anymore. But I mean, I had no idea what exactly was wrong at the point when I started to investigate. It was just like I flash it. I was exactly the same stage than Marco is now. So I'm flashing it. I'm expecting that it comes up, and it didn't. So I did a lot of specs with the kind of project plan with the AI in order to fix that issue, and that Disco tool came out of it, right? And then the Disco tool was able to fix these issues, which are more or less obvious. So I mean, it looks now like a lot of code if you look into this, but the thing is, like, I sat there and looked what the AI is doing, and it is either reasonable or it's not. It's not like it automatically does it, but you can try whether it works or not, and maybe it doesn't. And in many cases it doesn't, but it depends more or less on the guidelines you give to the AI. Right, and if you have proper guidelines what you would like to achieve, then it's less likely to go off the rails. And in most cases, you have to watch what it's doing anyway, because sometimes it's too difficult to. But this is something you have to play around with and have some experience and just try it out where you can trust it and when you cannot trust it. And build that trust that it will work and it doesn't waste your time so much or waste your tokens, which are also expensive, is something which just comes over time. But from my experience, it is working, and yeah, we just have to prove it.
So do I understand? So who will now try to bring up the hardware with the new LVGL version? Will you continue with that, or do you expect me to that? This is where I'm not quite clear on right now.
Let me continue with 1 week, and then I will do a demo, and maybe I will do the demo on your software, and then we will try to flash it there. Yeah, because I don't care so much whether I'm working on that part or on that other part, right? The first thing is to do the setup right, and if I have the setup right, it will, from my point of view, be much easier to get that progress going. That was my point, more or less, on the presentation I did, where I said, okay, you need the AI to touch ground. And that touching ground is really important. So it needs feedback, whether it's on the right track or not. And fixing these kind of issues gives them this hardware setup gives it the possibility to check whether it's on the right track or not. And that's why I think it is possible to do it. And then, yeah, give it a 1 or 2 weeks more, and I'm sure we will get your code working as well. There might be issues, for example, if the code is too big, and then we have a real problem, right? But if it's just tiny, stupid Python differences, then I'm sure we will get it going.
So if the Micropython port is not correctly working, I mean, the AI might need some inputs based on the actual board spec, I think, because the adaptation that would be needed is really low-level hardware stuff, like which pins are connected where, which drivers to use, and stuff like that. I think the spec is also in the repo itself, right? So the AI could look into those files.
I don't think we have the problem with on that level yet. So there might be problems with specific connections of the device internally. So, for example, is does the firmware can work with the camera? Does the firmware be able to work with the card reader? Does the firmware, such kind of things, right? But that is not relevant for your code because your code is not having that many functionality. Yeah, and
but for example, the connection to the display needs to be working, and that would be how the microcontroller is connected to the display. And that is something that is probably specific to the board that we're using. This is not, I assume.
No, hold on. I mean, we have already code which is working on the machine and is using the new LVGL code.
Where? I don't have seen that. Where's that?
Mike said that he got it working, and I don't have a proof.
Right, but then where is that code? If that code is there, then that would be where I would just start from. If that is there, then I will take that as a skeleton and from there expand, right?
Yeah, but well,
that's branch, where's that?
From my point of view, in the playground. And the playground, I haven't looked at the playground.
No, it didn't work. I tried it in the playground with basically a minimal example. So if there is something where you have the new LVGL, the new Micropython, and you can display anything on the real display, that's the branch, the main file that I'd be looking for, and from there I'd iterate, but I haven't found that. And if then I would like to know which one that is, and then I can start. But yes. I tried to construct such a minimal example in the playground.
This one.
And it didn't work.
I think it's the address navigator. He claims that he have got the address navigator running on the hardware. That's what he claimed.
All right, then I will try to verify that. That should be easy then.
Yeah. Yeah, but that's what, and I mean, maybe that's a minimum viable product, or POC could be that next week I prove that this is true by flashing this one on the, and then we can, because this is definitely supposed to work. But unfortunately, it's not. So Mike didn't send that proof anywhere, and we don't have a kind of straightforward kind of tutorial on how to do that and how he did it. So and therefore, yeah, this is a little bit odd, but I cannot change it. That's the way it is, and so I think we will get it working. I'm pretty sure about that. So that's my word. Next week we will see the address navigator on the device. Yeah, and by the way, here should be probably the is that here? Yeah, that's nothing. No, can't find it. Can't find it. Maybe here. No. Anyway. Next week.
I thought the meme is 2 weeks, right?
Yeah. I just thought about maybe say it's 2 weeks, but it will be 1 week. That's not a meme. Yeah, and maybe it's 2 weeks. Let's see. But we will get it going. So if we don't have anything else, then you might want to wrap up the call. And just a disclaimer once again, right? Because some people are a bit concerned about AI and its involvement in the Specter project. And it is not involved in the Specter project at all. It's a tool which is used by individuals. And whenever code gets serious, then human people are reviewing that code with whatever tooling they have, and they will click the approve button. And therefore, it's not that AI is able to mess with code on devices. It's always humans who are here the kind of gatekeeper and not AI. On the other hand, we cannot. So it's incredible what is happening right now in the software industry with AI. What is achievable there is just incredible, and we cannot deny that, and therefore it's not going away. In a similar way, like Bitcoin is not going away, AI is also not going away, and we have to somehow leverage that in order to shield us from, for example, security threats, right? Okay, V is writing review and tests. I'm looking forward to Specter profiling of all the Python that was done for other hardware wallets.
Profiting.
Profiting of all the Python that was done for other hardware wallets.
I'm not sure honestly what he completely mean, but maybe he means that like AI could use because some other projects did program anything, and if we can like give AI, because the other projects are open source, and we can like give AI, like show them the other projects, and then we can like our hardware wallet can benefit from Crux and Seed Center, for example, what they have for nice features. And I think even other hardware wallets, I'm not sure if they are like Python based, but maybe we can use we can like get something from them into our project. I think that's what you're saying, right? Or not you meaning?
Yeah. Okay.
Perfect. Yeah.
And just for reminder, because there is Francis Pulio. I don't know whether you know that name, but he is the kind of CEO from Bull Bitcoin, and he recently released the Bull Bitcoin wallet, which is a self-custodial ARC wallet. Very, very cool wallet. And he did a tweet the day before yesterday or something like that, that he needed to have a call with Anthropic. Anthropic is the vendor from the Claude Code, because he blocked him from using more plans. Because if people are maxing out their plans, then there is no way to enlarge the plan. And the way to deal with that is that you are purchasing another plan then, right? And I don't know how many plans he purchased, but he's claiming that he used somehow like 7 billion tokens or something like that, right? So I'm pretty sure that the Bull Bitcoin wallet has mostly been coded by AI.
Crazy shit.
Just a quick feedback to the address navigator. So I loaded the main branch of Specter Playground. I compiled it and if I compile with simulate address navigator, it's working. If I compile it with Disco address navigator and flash the script or the created bin over to the device, the display stays black.
And what is working? What did you say in the beginning is working?
The simulator is working.
The simulator is working. Yeah. Yes. Okay. Well, it was his claim, and it's.
But maybe you should first verify that, because maybe he has something special somewhere else. But at least on the main branch of the playground, it's not working.
Yeah. Let's see.
Just a follow-up regarding using other features from Crux or Seed Signer. I am doing optimization on the library for QR codes used by Crux. It's called called Foundation URPy, and it is on Micropython. So the issue I see is that Crux and SeedSigner was using this library normally, but the Disco board has low RAM and low disk space also. The firmware, I think it's 2 megabytes, the maximum size, more or less, and the memory is also 2 megabytes. So Stefan was handling QR codes, animated QR codes with parts, saving into the flash, each part into the flash memory of the device to not use RAM, and then combining those parts and giving only the result, the end result, back to the board. So it needs to be very optimized to run on the Disco board because it has low RAM.
Okay, yeah, that's unfortunate, but that's these kind of constraints we have to work with.
Yeah, so we cannot put so many features on the firmware. We would have to think about, we are doing this on Crux, it's not merged yet, but we called Crux apps. It's the ability to put a Micropython code into an SD card and then execute this code during runtime with signature checks. So we would have the firmware checking if the Micropython code is signed by the ones that authorize the execute, the developers. And if it is, it would run this arbitrary code, but it doesn't help with RAM, just with firmware size. So it's complicated. I was thinking about creating a way to run we would have to refactor the firmware to run minimal parts and use garbage collector to remove the parts that we are not using on the specific feature. Like PSBT, I think the QR codes PSBT can't handle too many inputs, but the version Stefan did using SD cards, it does the signing not on RAM, but on the file, on the SD card, incrementally. So it could handle 100 inputs, something like that. So that's the thing of
I can't believe that. I can't believe that, because if you don't do it via SD card, but if you do it via QR codes, it has to do it on memory, right? Or
yeah, because you read several parts, lots of parts, and you have to merge those parts together to get the PSBT file. Only if we would enforce to. It's just something that keep in mind that it's limited. We have limited resource, and we have to figure out ways to enhance the firmware. It's not that simple.
Yeah. So maybe at some point in time, maybe there's an update of the Disco board with some larger RAM and file system. Let's see. Hopefully, I don't know. Yeah, but I mean I'm not worrying about that, because it's so much down the line that that we have so many other issues to fix up front before we get to that problem, I think. Yeah, but let's see. Anything else? Yeah, then let's wrap up the call, and hopefully see you next week. Yeah, and I hope we will have some more results then.
Yeah, so
Thank
one
you.
thing about next week, there's Motorbroad joining, and he's going to like explain, maybe, I'm not sure what he's exactly explaining, but probably maybe like how he did the his Slimmest Specter. And yeah, that's one thing, and then we can maybe see what Jukka Neunert made with the hardware setup.
Yeah, yeah, and maybe you can, if you haven't done it yet, so then you can post the video from Motorbroad. If probably everyone saw it already here on the call, but that's
I have it in the video description, and it's also in the stream somehow.
Yeah.
Perfect. See you next week.
See you. Bye bye.
Bye, guys.
Yeah, bye guys.